China didn't go to Mars for the reason you think. Most people assume it was about prestige, planting a flag, catching up to NASA, beating Elon Musk to the red planet. That's the easy explanation, and it's completely wrong. China's Mars mission didn't begin in 2020. It didn't begin with a rover rolling across the surface. And it definitely wasn't designed around headlines. The real decision to go to Mars was made decades earlier. Quietly, methodically, as part of a much larger plan. Mars was never the prize. It was the test environment. Stay with me, because what China is actually building will change everything about space, and most people have no idea it's happening. If you want to prove you belong among the top space powers, you don't start with Mars. Mars is brutal. Its atmosphere is less than 1% as dense as Earth's, too thin for parachutes to work properly, but thick enough to cause extreme heating during entry. There's no real-time control. Signals take between 4 and 24 minutes to travel one way. Once a spacecraft hits the upper atmosphere, everything that follows happens alone. This is why engineers call it 7 minutes of terror. Historically, Mars has been a graveyard for missions. In 1971, the Soviet Union became the first nation to land on Mars with Mars 3. It touched down, transmitted a single grainy image, and then went silent forever, likely destroyed by a dust storm within seconds. In 2003, the United Kingdom's Beagle 2 probe reached the surface, but half its solar panels failed to deploy. It never powered on. Even today, more than half of all Mars missions ever attempted have failed. So when a country successfully reaches Mars orbit, lands safely and deploys a working rover, especially on its first independent attempt, that achievement doesn't prove ambition. It proves systems. It proves navigation, propulsion, thermal control, autonomy, communications, and engineering discipline working together across hundreds of millions of kilometers. That's why Mars success is considered elite tier, and that's exactly why China chose it. Tianwen-1 is often described as China's Mars rover mission. That description misses the point. On July 23, 2020, China launched Tianwen-1 aboard a Long March 5 heavy-lift rocket. 7 months later, on February 10, 2021, the spacecraft entered orbit around Mars. And on May 14, 2021, the Zhurong rover touched down in Utopia Planitia. But Tianwen-1 was never designed as a rover mission. It was an entire Mars architecture launched in one piece. A single spacecraft carried an orbiter, a lander, and a 6-wheeled rover together, all the way from Earth to Mars, on China's very first independent attempt. No secondary launch, no backup probe, no redundant lander waiting in reserve. If anything failed, navigation, propulsion, entry, descent, landing, or communications, the entire mission would have ended instantly. NASA has never attempted this on a first Mars mission, neither has Europe, Russia, or Japan. China did it anyway. Because this wasn't about maximizing science return. It wasn't about media images. It was a full-stack system stress test, from Earth departure to surface operations, under the harshest conditions planetary exploration can offer. And there's a reason China designed Tianwen-1 this way. It didn't have a choice. In 2011, the United States passed what's known as the Wolf Amendment, legislation that legally prohibits NASA and its contractors from engaging in bilateral space cooperation with China. The effects were immediate and permanent. China was locked out of the International Space Station. Chinese scientists were excluded from joint NASA planetary missions, and participation in US-led deep space programs became legally impossible. This wasn't symbolic. It was structural, and the pattern that followed is impossible to miss. Excluded from the ISS, China built Tiangong, its own modular space station. Excluded from cooperative lunar exploration, China launched the Chang'e program and became the first nation to return samples from the far side of the moon. Excluded from Mars missions, China built Tianwen-1 entirely on its own. Mars wasn't chosen to make a statement. Mars was chosen because independence had to be proven somewhere, and Mars is where dependence breaks first. By the time Tianwen-1 launched, going to Mars was no longer optional. It was inevitable. Drop a comment right now if you're starting to see the pattern, because this is just the beginning. So if Tianwen-1 wasn't just about exploration, what was China actually testing on Mars? The answer is simpler and far more strategic than most people realize. China needed to validate 4 systems that cannot be fully tested anywhere closer to Earth. First, deep space autonomy. Tianwen 1 spent nearly 7 months cruising through interplanetary space, covering about 470 million kilometers before reaching Mars. During that time, ground control could not intervene in real time. Commands took minutes to arrive, and decisions often had to be made on board. Navigation corrections, system health monitoring, fault detection. All of it had to work without constant human input. That's the kind of autonomy you don't need for Earth orbit. But it's exactly what you need for future missions that last years. Second, planetary landing systems. China deliberately chose a conservative but proven architecture, a parachute to bleed off speed in Mars's thin atmosphere, followed by retro rockets for final descent. It's the same basic approach NASA used successfully with the Viking landers in the 1970s. Not flashy, not experimental, reliable. By using this system, China wasn't trying to innovate. It was trying to validate. Could it repeatedly deliver mass safely to another planet's surface? Third, surface operations under real Martian conditions. Zhurong was solar-powered, not nuclear. That meant dust accumulation, reduced sunlight, and seasonal temperature swings were existential threats. The rover had to survive freezing nights, intense radiation, and regional dust storms, all while operating far from human intervention. Eventually, Zhurong entered a planned hibernation in mid-2022 to try to ride out worsening conditions. That outcome wasn't a failure. It was data. Finally, interplanetary communications. The Tianwen-1 orbiter didn't just observe Mars, it acted as a relay, passing data between Zhurong and Earth. This validated China's independent deep space network, tracking, command, telemetry, and data return, without reliance on NASA or ESA infrastructure. Put together, these 4 systems explain the real motive. Mars wasn't chosen because it was exciting. Mars was chosen because it is the harshest possible laboratory. If your systems work there, they work anywhere. None of this means the science was fake. Far from it. Zhurong was equipped with a serious scientific payload. A ground-penetrating radar capable of probing deep below the surface, multispectral cameras, surface composition spectrometers, and a magnetometer to study Mars's crustal magnetic fields. And what it found mattered. As Zhurong traversed Utopia Planitia, its radar detected dozens of layered structures buried between roughly 10 and 35 meters below the surface. These layers weren't flat, they were tilted, sloping consistently in one direction. On Earth, that geometry is unmistakable. It's what coastlines look like after millions of years of sediment buildup. The implication was clear. Zhurong had landed on the remains of an ancient shoreline, formed by water flowing from the southern highlands into a northern ocean. Even more striking was the timing. Some of the hydrated minerals detected by Zhurong appeared to have formed far more recently than scientists had expected. Long after Mars was assumed to be completely dry. That pushed liquid water on Mars hundreds of millions of years closer to the present. And that's why Utopia Planitia was such a deliberate choice. It's part of Mars's vast northern lowlands, believed to be the basin of a long-lost ocean. It's geologically stable, relatively flat, and rich in buried history. A perfect place to do 2 things at once. Advance planetary science while quietly validating every system required for permanent deep space operations. The discoveries were real, but they weren't the finish line. They were proof that the test was working. Tianwen-1 wasn't the end of China's Mars story. It was the opening move. The next step is already scheduled. Around 2028, China plans to launch Tianwen-3, a full Mars sample return mission, not a flyby, not a rover extension. A mission designed to land, collect material, launch back off the Martian surface, rendezvous in orbit, and return samples to Earth. Only one other space agency is attempting that level of complexity. Beyond Mars, Tianwen-4 is planned to explore the Jupiter system, pushing China's operational range far beyond the inner planets. That matters because missions to Jupiter aren't about headlines. They're about radiation hardening, long-duration power systems, and extreme autonomy. At the same time, Chinese space roadmaps openly discuss crewed Mars missions in the mid-21st century, not as a single landing, but as a sequence. To support that, China is developing Long March 9, a true super-heavy lift rocket designed to carry payloads large enough for deep space assembly and sustained operations. And quietly, but not secretly, Chinese researchers are studying nuclear thermal and nuclear electric propulsion. The kind of propulsion you don't need for flags and photo ops, but absolutely need for cargo, cruise, and repeated interplanetary travel. None of this exists in isolation. These systems are expensive, they take decades to mature, and they only make sense if you expect to use them again and again. That's the real reason China went to Mars, not to plant a flag, not to win a headline, but to prove that every single component required for permanent deep space presence works independently. Mars was the certification test, and China passed. Now the question isn't whether China can reach Mars. The question is what they're building Mars capability for. If this made you realize space exploration is far more strategic than you ever thought, smash that subscribe button. Because here at the Curiosity Beast, we expose the plans hiding in plain sight. Drop a comment telling me if you think China will beat NASA back to the moon in 2030. Because that race is happening right now.